Hello everyone. So what you're about to see today is something incredibly interesting because it has not yet been seen before. Some of you who have been following Dotmatics may know that recently we have been acquired by a larger American corporation, which gives us more money for more exciting research and comes with a nice new branding detail, so you'll see some of that as we suddenly switch throughout this. So, there we go. So I'm going to start with a little bit of who I am. We've had the bio, but there's a little bit more of a rundown. What is Dotmatics? As I realize that some of you are not really familiar with Dotmatics or really the usage of ELNs, so I'll go through that a little bit. And then finally, some AI in chemistry at an industrial scale. So first off, here I am. Data scientist is only scratching the surface of what I do at Dotmatics. I am on call during times of crisis. I travel here, there, and everywhere. This time next week, in fact, I will be in Santa Fe. And making networks is very important in industry, and so we like to walk the halls because there is no point in doing what we do unless we know that it's what our customers require. So we go on site, we see what they're doing in their labs, and we develop in our team prototypes that will eventually work their way into the finished products. So, Dotmatics, but bigger. So, as I mentioned, we've been acquired. This brings under the Dotmatics banner well-known favorites like GraphPad Prism, SnapGene, Protein Metrics, all these other ones, Genius, Prime, and Biologics for those who are into biochemistry. And one of the companies I've been working fairly close with, which is BioBright, who produce a lot of equipment that hooks into lab instruments so you can get live-streamed data directly into your Dotmatics instance. So, as an organization, we work with these tiny startups here, GSK, Pfizer, Roche. You know, I think we're going to hear of them in the next few years. So these customers trust us with their data because we make sure that everything is very thoroughly audited. We've recently been through GXP accreditation, so that is to make sure that what we say we are doing with your data is what we are doing with your data, and everything has various levels of encryption on it, so people know that they are in safe hands. And in fact, just a point, when I said we are carrying out our AI work on billions of dollars worth of data, we don't pull the customer's data into what we're doing, we take the algorithm to the customer, which is going to come up a little bit later. So just some of the sort of mandatory corporate slides. We run through the flywheel of the test, decide, and make cycle so that everything that you do can influence the next thing that you do, but this allows it to happen at a greater rate. What we are founded on is the principle that data siloing is dangerous, and so to be able to centralize that data in a manner that can be run through a federated search really just increases the efficiency of what you're doing. So we have our classic electronic lab notebook and a fully GXP accredited lab inventory management system, so you can even track the concentration and amount of compounds that you have coming through your lab. We have the analysis and acquisition steps during the test, and then modeling, visualization, and prediction. So this is where our various partner products come in. But then, because we don't really make products, we make elements of a workflow more than anything that are meant to hook up together, we can configure these in all kinds of ways depending on what the needs of our customer are. So rather than just saying, this is our product, go ahead and use it, we say, what do you need? How can we provide you a solution to your problems? And many of our customers start with paper lab notebooks, and as I'm sure many of you know, it's very difficult once you enter a new lab to really get up to speed on what's going on. So if all that data is in one place, it's very easy for anyone to enter the lab and just look through past experiments. So two of our most popular products here, Vortex and Browser. Browser is the federated search functionality, and Vortex I will show a little bit of in a moment because I live dangerously and like to do live demos. In fact, the people in the bar with me last night will realize that I make questionable decisions, and I guess this is one of them. So now on to high throughput edge computing. So first, as I mentioned, we have an electronic lab notebook. Now, you sacrifice some of the freedom of a paper lab notebook, as in you can't just write anything anywhere, but you have a web form. And if you are running the same types of experiments multiple times, That standardized layout means that you can put the data into the database in a very well-formatted way so that when you need to bring it out again, it is just as easy as putting it in. Users can make, well, admin users can make their own forms, which will allow both for the searching and the data entry. And so it can be very easily customized to exactly what users want to do and then modified with various other back-end pop-ups, various searching. There's a lot of systems query language in there, SQL for those who use that. And we do some server-based computing, but it does have its limits when it comes to high-throughput machine learning. So typically, there'll be so many pings backwards and forwards. The user will pull the data out the server. They'll want to run a calculation, so they'll push it back into the server. The server then brings them the data back. And then if they want to save it, they push it back into the server. The problem with that is the longer these queries take, as some of these queries are fairly complex, the more queries you have per second, that starts to slow down all of the querying for all users all over the world, because a lot of our larger instances, there are users globally on them. And so if you need to have a larger number of connections, you'll need a larger server, whether you're hosted in-house or whether you're run on an Amazon Web Services instance. It can get very expensive. So one way to get around this is to run edge computing. So if you're using a low-level language, such as C or C++ or Rust, you can compile that directly into assembly language that can be run in a web browser. And so in this instance, we decided to start pretty easily with some artificial neural networks in a web browser. And for anyone who has ever mocked people that do machine learning in JavaScript, this is not your average JavaScript. So the user retrieves the page and the data and the algorithm to the page, which then runs in what is known as a web worker, essentially a separate thread in a web page. So everything that you're seeing does not stop the web page from functioning. Everything is happening in the background, almost like you've got a second tab open and something's happening in that tab, but it's hidden. And then if you like the results, you can send that to the database. So the number of cores you have is the number of users you have, and that makes everything a lot safer because there are fewer chances for anybody to intercept with the fewer pings that you have. So this was going to be a static image, but this is one of the moments where I'll do a live demo. So one of the joys of using WebAssembly for machine learning is you can watch it live in real time as it's doing its thing. Whereas if you're doing something on a server, you would need to wait for it to finish calculating and send it back. So here we have our Alzheimer's demo project. This is quite a classic example of the project I like to use for this kind of stuff. So we can run a query, and we will retrieve about 2,500 compounds here. This machine learning model management menu will come in very handy later. But now let's send it to our neural network demo. So this uses xlog-p, which is, in short, a solubility metric. And the prediction is made based upon a binarized string of features in the molecule. So it's directly based on the molecular structure. So then that query gets passed to the neural network, and as we can see, it is training in real time and aligning upon the central line of predicted versus observed. And the user can even look further into this by mousing over a compound, and if they want to see how a compound may react, let's find one that's a little nicer to modify, they can then just modify the... I have really messed that one up. There we go. In situ, modify the compound, plot a prediction, see how the value might react on the testing side plot. So on top of that, we want to provide our users with very thorough graphing. So we've been developing a very interactive graphing library in terms of understanding continuous time series. So this is where our friends at BioBright come in. And you can understand over a period of many years how your assays are developing. But this isn't necessarily the most useful view. So let's say you want to take a year slice to show how you've done in the previous year. So you can just click and drag and then drop into that individual space of time. Similarly, if you want to hide one of the lines, that's easy enough to do as well. So the user can then export this as PNG or JPEG and has complete control over the data that they want to present to whoever they're showing it to, be it stakeholders, be it colleagues. So this is frankly something I've enjoyed doing, and if you've been doing something for a long time under high pressure and you still get some joy out of it, I think that's a very good sign. So similarly, we have our data science tool called Vortex. As you can see, this is essentially the same data set, just with a newer and... Is it not?
No, not according to the chat. Yeah.
Oh dear, okay. Am I just showing PowerPoint and I completely missed out on all of that wonderful goodie? So, here we go. Here's what I should have been showing. Is that all coming up through Zoom? Okay. Everyone is way too polite here. So, again, to go back through what I was talking about, we run the query. So we can see these 2,500 results here, and this is what you should have seen, everything moving nicely. As you push it into the neural network, we can see it training along the central line. Once it's done, as I mentioned before, we can then modify the compound if we actually click in the right place, and then plot it on the training graph. So this is predicting, as I mentioned, using log P, which is essentially a solubility metric. And I won't go through it for too long, but as we can see, here is that plot of time series. Users can zoom in, users can mouse over, and then export it in whatever state they want to leave the plot in. So plenty of different ways to use that. So then also, I won't show that now because it'll be slightly time consuming, but we can also do the same in Vortex if we want. That gives us more tools to manipulate the data. And also we have an up-and-coming tool we are about to release where users can query using Tanimoto comparison the entirety of the enamine real data set. Now this is, as of the most recent version, 6 billion compounds that are currently purchasable right now. And my boss has done some crazy magic that allows it to search 7.8 billion compounds per second and retrieve you the most 500 similar. So this will allow an almost Netflix-like suggester system where it says, this is the previous set of compounds you've researched on. Based upon this, we think these compounds might help. And so we give the power of someone who may have been in chemistry for 30 plus years to someone fresh out of university. So the potential for this is very powerful. So this was the continuous process monitoring that I expected to not show, and I almost didn't, clearly. So I will skip over this. And the final note is, because we're growing so quickly, we are hiring for many positions. If you're into product management, we've got that. We have spaces in the science and technology team, which I think will be of more interest to people here. But there are so many different roles going, and even if you think that you don't have the computational skill, trust me, you gain it incredibly quickly. As for those who didn't get the chance to snap up one of the Dotmatics notebooks before the branding changes, there are a few more in that corner. So feel free to drop by and pick one up, and I will be exhibiting later, so I'm happy to talk to any one of you, and thank you for listening.